Okay, we're starting chapter 9 today. We're talking a lot in this chapter about right triangles. So when we talk about right triangles, we use Pythagorean theorem a lot to help us solve for missing sides. Okay, so on page 1, this only works for right triangles. So in a right triangle, the sum of the square of the lengths of the two legs is equal to the square of the hypotenuse. Now, those are already labeled in this picture for you, right? The two legs meet at a 90-degree angle. We call those A and B. The hypotenuse is always located across from that right angle, and we call that side C. So, does anyone remember the formula for Pythagorean theorem?
A squared plus B squared equals C squared.
Perfect. A squared plus B squared equals C squared. Okay? Now, this is one that we should remember because you will use it a lot, right? And I actually think we've used it already some this year in some of our other problems. Anytime, you guys, that you see a triangle and it's a right triangle and you have two of the three sides, this formula will always work to solve for that missing side every single time. Even if that's not the type of problem that they're asking you to do, it will work that way. Okay? So the only side that we care about, that we need to identify, is the hypotenuse. So in example 1, which of these three sides is the hypotenuse? X, because it's across from the right angle. So we replace that for C. Okay? So it's going to be equal to x squared. The other two numbers, it doesn't matter which one you write first. So we're just going to say 5 squared plus 12 squared. Okay? What is 5 squared? And 12 squared? 144. Okay, we know we have to add those together. We get 169 is equal to x squared. Now, the only problem is we're trying to solve for x, and we have x squared. Who can tell me how I could get just x? Square root. Remember, square root is the opposite of square.
Excuse me, these students need to come to the office. Dylan Avery.
What's the square root of 169?
13.
Hess
13.
Butler, Isai Casio, Deegan Hartzell, Jackson King, Gentry Clausen, Ethan Keimer, Lace Menon, Angel Morales, Mia Mosier, Riley Petit, Rayleigh Phillips, Estefania Quintana, Aaron Rivers, Tallulah Sankadota, and Brielle Wetby, and Sunny Dennis.
Okay, so, yeah. Same thing on the second one, right? We set it up the exact same way. First, identify the hypotenuse, which is what? X. Same thing here, okay? So, we're going to do 39 squared plus 52 squared is equal to x squared. I'm going to move quickly through this because I think you guys are okay with this part. Agree? Are we okay with the setup of it? Okay. All right. So, we get 1521 plus 2704 is equal to x squared. When we add those, that gives us 4,225 is equal to x squared. Just like last time, the opposite of squaring is to take the square root. The square root of 4,225 is 65. Simple enough, yes? Okay. I'm going to try to go quick so we have a little more time to do our work. Okay, a Pythagorean triple is a set of positive integers that satisfy the equation y equals mx, or sorry, that's just in my brain. A squared plus b squared equals c squared, okay? So, if we want to know if something is a Pythagorean triple, a squared plus b squared has to equal c squared, right? If you square the two numbers and they don't equal c squared, then it's not a Pythagorean triple. It's that simple. So, how could I check if example 1 is a Pythagorean triple? What did I just tell you to do? What did I just tell you to do, you guys?
Put them together
Like-
A squared.
Okay, say it again, Stella.
A squared plus B
Yes, just do a squared plus b squared equals c squared. So what numbers am I using?
12, 16, 20.
Come on, be confident. 12 squared plus what?
16,
16 squared is equal to,
20 squared.
don't make this difficult. You can type this whole thing in your calculator. 12 squared plus 16 squared. Saves you time. What is it? 400? What's 20 squared? 400. So is this a Pythagorean triple? Yes. Okay. Example 2, we're going to do the exact same way. 15 squared plus 36 squared should be equal to 40 squared. Again, you can type 15 squared plus 36 squared in your calculator. Somebody tell me what it gives me. 1521. What's 40 squared?
1600.
Okay. Are those two equal?
No.
No. So not a Pythagorean triple. Okay. Now, I'm not going to spend a lot of time on this right here, but over on the side, it gives you a list of like common Pythagorean triples. Okay. I am going to kind of draw a little like some lines between, because we're going to write some more things under this. No. Okay. So it gives you a list of common Pythagorean triples, right? So what it's telling you is if I do a squared plus b squared equals c squared, it's true on all of these 4 sets of numbers. Do we understand that? Yeah. So all of these are Pythagorean triples. Now, the other thing that can happen is if I double each of those numbers, so I multiply by 2, what do I get if I double 3? What number?
6.
What about 4?
8.
And 5? 6, 8, and 10 are also Pythagorean triples. Okay? So you can go through, we'll do this later, I'll come back to it just for time's sake. Well, let me just write them in for you real quick. So 10, 24, and 26. And then 16, 30, and 34. 14, 48, and 50. Now, I don't expect you to memorize these. 3, 4, 5 is the most common one. Like when you see 3, 4, 5, you should know it's a Pythagorean triple. Everything else, you can just always check. A squared plus b squared equals c squared. Because the truth is you're not going to memorize these. And that's fine. Like I don't have most of these memorized. Because I would just do a squared plus b squared equals c squared. But I'm giving them to you so you have them. Okay? So doubling them works. Tripling them also works. So if I triple that original column, 3, 4, 5, what would that be?
9, 6, 9, 12, 15.
9, 12, and 15. Good. Okay, I'm going to give you the rest. 15, 36, and 39. 24, 45, 51. And then 21, 72, and 75. Okay, so that way you just have this list. You can refer back to it if you need to. Okay, is this all Pythagorean triples? No, these are just common ones, and they're multiples. Fair enough? Okay, all right. Okay, back page. Let's go quick. All right. Same thing on the back page. It's asking us to solve for the missing leg of a right triangle. What formula can I use to solve for any missing side of a right triangle? Okay, the only thing I need to identify is which part of the triangle. Which is what? 15 is my hypotenuse. So we're going to say x squared plus 13 squared is equal to 15 squared. Okay, so we get x squared plus 169 is equal to 225. Bless you. The difference here is what extra step do I have to do to solve? Subtract 169. So I get x squared is equal to 56. The other thing here that we haven't seen yet is we've had all perfect squares. Is 56 a perfect square?
No.
No, so what am I going to have to do to simplify?
Find out.
Factor, right? Again, for time's sake, I'm going to give that to you. It's 4 times 14. So what would my final answer be?
414.
Not 414,
214.
214, right? We take the square root of 4, 2 square roots of 14. Okay? I want you to try example 2. It's the exact same as what we just did. Remember, you can use your square and square root chart on that page or two before to help you when you need to simplify at the end. Anybody got an answer for me yet?
Is it 3 square root of 64?
Yes, but you didn't finish it. It is 3 times 64, but what would be your final answer? 8 square roots of 3. Remember to take the square root of 64. Okay, so you should get x squared is equal to 192. Did we all get that? Did we all get 192?
Mm-hmm.
Okay, I know some of you were still working on the other part. It's 64 times 3, and then the square root of 64 would give you 8, remainder square root of 3. Okay? Questions on that, or are we okay? I'm not getting any kind of answer.
We're okay.
Okay. All right. Finding a radical side length, you're going to do the exact same thing. It wants you to find the diagonal, so you have to draw that in first. If I draw in a diagonal, what kind of figure do I have now on the top? Specifically a right triangle. So can I still use a squared plus b squared equals c squared? Yes. Okay. What's the hypotenuse? X. So 4 squared plus the square root of 24 squared equals x squared. Okay, what is 4 squared?
60.
And what is the square root of 24 squared? 24. Good, we just did this yesterday. Square and a square root just gets rid of it, equal to x squared. Okay, so I get 40 is equal to x squared. How do I get rid of the x being squared? Square root both sides. So now I have to decide what numbers multiply to get 40 that include a perfect square. 4 times 10. Okay, and that would give me a final answer of what? 2 square roots of 10. Good. Remember, we take just the perfect square out front. The other part stays underneath. Okay. Are we noticing that we're pretty much using the same pattern every time? Okay. It should kind of help you move through most of these fairly quickly. All right, same thing on example 2. It says a rectangle has a diagonal length of 4 square roots of 6 and a width of 4 inches. It wants you to find the length of the rectangle. Put your answer in simplest radical form. So can anyone just set this up for me here?
X squared plus 4 squared equals 4 6 squared.
Good. 4 square roots of 6 squared. I'm going to put that in parentheses. Okay. Now, we know 4 squared is 16 because we had that same one on our last problem. What about 4 square roots of 6 squared? We haven't really seen this yet. How do I work that out?
Just do like factor first and then square.
Factoring won't really work because there's nothing to factor from 6.
Square root 4.
Square root 4?
Square 4.
Square 4. Yes. Because remember, it's just multiplying this by itself. So essentially, I could write 4 square roots of 6 again. So we multiply 4 times 4 to get 16. And then what's the square root of 6 times the square root of 6? Just 6. So this is really 16 times 6. Agree? The other thing you could do is just square each number. Because 4 squared is 16. Square root of 6 squared is just 6. Okay? So we get x squared plus 16 is equal to 96. I subtract 16 from both sides. I get x squared is equal to 80. We know our last step is to square root. Anybody remember what two numbers multiply to get 80? I thought somebody said. Has to be perfect square. 4 and 20 works, but that's not the biggest possible perfect square.
16 and 5.
16 and 5, yeah. So we take the square root of 16, we get 4 square roots of 5. Okay. All right, last thing. You can use the Pythagorean theorem converse to help you identify a specific type of triangle based off just the side lengths given. You don't even have to have a picture, okay? If you can do a squared plus b squared equals c squared, then it's a right triangle. If you do a squared plus b squared and it's greater than c squared, it's an acute triangle, which means a squared plus b squared less than c squared is obtuse. So we can use the same idea we've done and then just based off our answer, that will tell us right, acute, obtuse. Yes? Now, the first thing you have to figure out is, can the 3 lengths even form a triangle? Do you guys know how to tell if you can form a triangle based off 3 side lengths?
It has to equal. Oh no, that's different.
Just add. You add the 2 shorter sides, has to be longer than the third side. Okay? So, what's 6.2 plus 13.8?
20.
Is 20 greater than 20?
Yeah.
No, right? So this, not a triangle. Those are the easy ones because you don't have any extra work to do. Okay? All right, what are my 2 shorter sides on example 2?
5.8 and 3.
What's 5.8 plus 3?
8.8.
Is 8.8 longer than 7?
Yes.
So this is a triangle. So now we're going to test a squared plus b squared equals c squared. Okay? Who can tell me what numbers I use for a and b?
5.8 and 3.
Yeah, the 2 that we added together. Okay? So 5.8 squared plus 3 squared and 7 squared. Now, can you type that whole first part in your calculator? 5.8 squared plus 3 squared? Yes. Save yourself some time. What is 5.8 squared plus 3 squared?
42.64.
And we should know 7 squared is,
49.
what type of symbol would I use here? Less than, greater than, or equal to?
Less than.
Okay. So if 42.64 is less than 49, what type of triangle would this be? Obtuse. Good. right? Because up here we talked about obtuse, a squared plus b squared has to be less than c squared. Okay? All right, on example 3, before we start this one, we should use our calculator to figure out what number this even is. So do 3 squared to 34, and somebody tell me what you get. Just round to the tens place, it doesn't matter.
17.5.
So this number is 17.5, so that's our longest side. So what two sides are we adding together?
15 and 9.
What is 9 plus 15?
24.
So is this a triangle?
Yeah.
Yes. So now we test. A squared plus b squared equals c squared. Okay. Somebody do 9 squared plus 15 squared.
36.
Okay. Now, remember earlier I told you we can basically square both numbers, right? So what's 3 times 3?
9.
What's the square root of 34 times itself?
34.
Just 34.
9 times 34.
What is 9 times 34? Okay. So if they're equal, what type of triangle is this?
The right triangle.
Right triangle. Okay, we are out of the book today. Remember, those are posted online as well, so you can use those if you need to. Okay?